All right, hello everyone, and welcome to online lecture 9. So last time we were talking about variability, which essentially is the amount of spread. And we looked at one measure of variability, which is the range. And while an okay measure, it left something to be desired, right? Because it only looked at the high, the maximum, and the minimum scores, right? Or the highest and the lowest. So it's not really as helpful for giving us a true measure of spread. So we would now like to talk about the variance and standard deviation, which are much better and very related measures of spread. So variance is the measure of how spread out a set of scores are. Okay, it's a measure of variability. It's going to tell us about spread. Okay. So basically the idea is you find a central point. You find the distances or deviations to that point. You add these and take the average. Kind of makes sense, right? In theory, that's what we would want to do. Find a central point. How far are things away from that point? Take the distances, add them up, get the average. Makes sense. Okay. So let's work that through using an example. Let's take a set of 5 numbers, and the numbers will be 2, 4, 6, 8, 10. Very first thing we want to do before anything else is get the mean, because we're going to look at distances from the mean. Okay, so if I add up 2, 4, 6, 8, and 10, I would get 30. If I divide that by 5, because there are 5 numbers, 2, 4, 6, 8, 10, I would get 6. Okay, or 6.0, really, if I use the rounding rule, because all these numbers have 0 decimals, so I'd have 1 decimal in my final answer. Okay. So we have our average, our mean. Now what I want to do is look at the distances from each point to the mean. So I start off and say, how much is 10 minus 6? The answer is 4. Okay, how much is 2 minus 6? How much is 2 minus our mean? The answer is negative 4. Now let's do the same thing with the next set of numbers. 8 minus 6, 2. 4 minus 6, negative 2. And let's not forget, 6 minus 6, our central number here, is 0. So we want to basically have the average in some way of 4, negative 4, 2, negative 2, and 0. So what happens if we add up 4 and negative 4? Get 0. 2 and negative 2? Get 0. So we have 0 and 0, and one more 0 gives us 0. So when we go and try and divide that by 5, we're not going to get any variance. Okay, so that's a bit of a problem, isn't it? And I will tell you that this will happen every single time you try to use this method. So someone came up with a solution. And what I would ask you is, now what's a way to get rid of the negatives? Okay, because that's what's causing us the problem, right? So what's a way that we could sort of do to all the numbers so that we wouldn't wind up with all these, with just a 0 when we add them up? And when I ask this question, I usually get 2 answers. One is take the absolute value, which makes sense. Then I'd have 4, 4, 2, 2, 0. I would not get a 0 when I added those up. The other answer I usually get is to square the numbers. Now, it goes a little bit beyond this course to talk about why squaring the numbers is actually a slightly better answer. in terms of getting a good estimate of variance than is just taking the absolute value. So we will go ahead and square the numbers. Okay. So we're going to now calculate the variance of a distribution by finding the deviation difference score for each score, subtract the mean from each score, and then we're going to add in a step where we square those differences. Okay, and you notice I use the word difference and deviation kind of back and forth. Deviation is more the common language for this, so if you can get used to deviation, that would be great. So we found the differences just like we did before, and this time we're going to square those differences. Then we can add them up. Then we divide by the number of scores to get the average of the squared deviations. Okay, so sometimes people like to have a mnemonic or an abbreviation that kind of helps them remember this process. So what I usually talk about for a mnemonic, and please feel free to come up with something better, is SUSAD. So it's SU from subtract, it's S from square, it's A from add, and it's D from divide. So it's subtract, square, add, divide. That's all you have to do to get your variance. Okay, so once you have your mean, subtract, square, add, divide. Okay. So now here we are again. Let's see if this method works a little bit better. Okay, so now we have our 4 and -4, our 2 and -2, and our 0. So we take -4 squared, we get 16. We take 4 squared and we get 16. So we're up to 32. We take -2 squared and we get 4, and we take 2 squared and we get 4. So we're up to 40. Plus 0 squared is 0, so we're up to 40. 40 divided by 5 gives us 8.0. That seems awfully high, doesn't it? I don't really buy the fact that 8.0 is the actual spread of this distribution. So what can we do? We squared everything. That's what's making this number so high. I mean, it was nice. We got rid of the negatives, but as a result, now we have this really high number. Okay. So this is where standard deviation comes in. It's a return to the original scale. And this is the most widely used way of describing the spread of a group of scores. It's the average amount the scores differ from the mean. So to calculate the standard deviation, all you have to do is take the square root of the variance. So let me be really clear about this. We're not going to start from scratch here. We're not going to start over with our raw data. We're just going to take our variance and take the square root. Okay. So in this case, our variance was 8.0. If we take the square root of that, we get approximately 2.8. So that's how we want to proceed when we're getting the variance and standard deviation. We, excuse me, we square everything when we're getting the variance, and then we sort of undo that squaring by taking the square root when we get the standard deviation. Okay. Hopefully you're feeling okay about this so far. Remember, we are going to do some practice with this in our class, so stay tuned for that. Okay. So now that you're feeling good, let's go ahead and look at the formulas for the variance and standard deviation. Now, these will be a little more elaborate formulas than we have been working with to date. Okay. All right. Let's start with the population variance. Let's start with the population variance, okay? Now that's pretty much what we talked about. And let's actually start with the left side of this equation before the equal sign. And you see this funny looking symbol here, and it's squared. And what does that symbol stand for? It stands for population variance. And what does this little O with the little tag on it mean? It stands for sigma. So sigma squared is population variance. Now I know we used the term sigma once before, and that was to add everything up. Well, in Greek letters, there's an uppercase and a lowercase. And so that's what we're experiencing here. So I know they mean very different things and they look very different. Unfortunately, they have the same name. There's not much we can do about that. So I'm asking you to recall that even though I know that the one that looks kind of like an E is sigma and means sum it up, this is a different sigma, sigma squared here, and it looks different and it means something different. It means population variance. Okay, so now let's look at the right side of the formula. How do we calculate population variance? Just like we talked about, it's SUSAD. So we take our score and we subtract the mean. And this might be helpful to remember that mu stands for the population mean. So score minus mean, subtraction. Next, we square those values. So we take each score minus the mean and square it. Subtract, square. Subtract, square. Subtract, square. Keep doing this until you've gone through all the numbers in your data set. Now when you have all of those squares, you're going to add them up. There's that other sigma. Add them up. And then finally, you're going to divide by the number of points, a number of numbers in your data set. So it's subtract, square, add, divide. Okay. So that's population variance. Next, let's talk about population standard deviation. Okay, so we've done something to the left side of the equation and we've done something to the right side of the equation. Let's start with the left. What did we do? We have sigma squared here and we have sigma here. That's the only difference. Okay, let's come back to that. On the right side, here's our big variance equation. And on the right side here, here's our big standard deviation equation. What's the difference between the top and the bottom? The only difference is in the bottom, we took the square root at the very end. So again, remember, when you're calculating standard deviation, you don't start over. You start with variance, whatever you got here, and then you just take the square root. So I want you to think of it as variance plus one more step. Okay? All right, now let's go back to this left side. So we took the square root of the right side. We've agreed to that. What we're actually doing with the left side is taking the square root as well. And let me show you why that's true. So here we have sigma squared, here we have sigma. So let's say we took the square root of 2 squared. Okay, so that's the square root of 4, which is 2. So the square root of 2 squared is 2. Okay, let's take the square root of 4 squared. 4 squared is 16, square root of 16 is 4. Oh, so the square root of 2 squared is 2. The square root of 4 squared is 4. I'll tell you that the square root of 27 squared is 27. And the square root of 463 squared is 463. In other words, the square root of anything squared is itself. So what's the square root of sigma squared? Sigma. So that's how we got it. We took the square root of the sigma squared, we took the square root of the right part of the equation, and that's what we end up with. So just like sigma squared on the left side equals population variance, sigma on the left side equals population standard deviation. All right, we're halfway there and we've actually done the harder half. Let's move on. Now we're going to look at sample variance and sample standard deviation. Now, what's different between the left of population variance and the right of sample variance? Well, let's start looking at it. We've got score, that's the same, minus the mean. This was a population mean, the mu. X bar is the sample mean, X bar. So we still have score minus the mean. We're still squaring it. We're still adding them up, adding up all those squares. Here's where it's different. Over here, by population variance, we divided by the number of scores. In sample variance, we divide by the number of scores minus 1. So if you had 5 scores, you'd be dividing by 4. If you had 11 scores, you'd be dividing by 10. Now there is a rationale behind this. I often get asked at this point, why n minus 1? And it has to do, I can only briefly explain right now, we'll get to a better explanation later on, I promise. But right now all I can tell you is that sample is more of an estimate than population, and we are adjusting for that estimate by doing n minus 1. Okay, so we're making, you'll see, we're making our sample variance a little different from our population variance. We're making it a little larger. We're making our sample variance a little bit larger than a population variance. Okay. Now, I don't need you to worry about that last part unless you're interested. And like I said, I promise we'll get to a better explanation later on. Okay. So all we have left now is the sample standard deviation. Here you go. All we've done, once again, is taken the square root of both sides. Square root of s squared has to be s. Square root of this piece is square root of this piece. So once again, sigma squared equals population variance. Sigma equals population standard deviation. S squared equals sample variance. S equals sample standard deviation. Okay, so just to run through this last piece, we've got score minus mean squared, square of those differences, square of those deviations, add those up, divide by n minus 1, number of scores minus 1, and take the square root. And once again, remember, when you are getting to standard deviation, don't start from scratch again. It's just variance plus one more step. Okay. All right. So I think we're ready to use these formulas. So let's look at variance and standard deviation. Let's actually work through an example together. So the first step is to take all your scores, add them up, and divide by the number of scores. Well, there were 10 scores, so we divide by 10. Now that doesn't change. Just to be clear, the way we get the mean doesn't change regardless of whether we're in sample or population land. Only that last step there that we were talking about changes. So the mean so far, it doesn't matter whether we're doing population or sample, we get the mean the same way. We always get the mean the same way. Okay, so we added all these up. We got 60, we divided by 10, we got 6. Now we're going to subtract the mean from each score. And you see we have 7 minus 6, and 8 minus 6, and 8 minus 6, etc., etc. Notice we have some negative numbers here when we do 3 minus 6 and 1 minus 6. Okay. Now remember, if we added all these up, and you can try this as an experiment if you so desire, you would get 0. So we can't do that. We've got to square these numbers. So 1 squared is 1, 2 squared is 4, 3 squared is 9. Excuse me, that should be a negative 3 squared, it's still 9. Negative 5 squared is 25, etc., etc. Okay. So again, there's a little error here that should be a negative, but it still equals 9, so we're still okay. All right. Now we're going to add up our squared deviation scores. So we add up all those squares we just got, and we get 66. Okay, so far we've subtracted, we've squared, we've added. And you know what? We still haven't made a decision as to what we're actually calculating. Are we getting the population variance and standard deviation, or the sample variance and standard deviation? Well, the truth is we haven't had to make a decision yet because they're both the same in terms of calculation to this point. Let me say that again. They're both the same in terms of calculation to this point. Now, however, we do need to make a decision. Now we need to decide, because now we're either going to divide by n if we're in population land, or n minus 1 if we're in sample land. So let's go ahead and say that we're in population land, and we divide by the number of scores. So 66 divided by 10 is 6.6000, which becomes, when we look at the rounding rule, 6.6. So I want to talk about this for just a second because there's a couple of interesting things here. Why did I put these 3 zeros here? Well, here's the thing. When you're going through a whole bunch of calculations, which hasn't really come up until now, you want to hold on to 4 decimals. Excuse me, that's 4 numbers after the decimal place. Hold on to 4 of those until you get to the end, then apply the rounding rule. So why is the rounding rule, why is it 6.6? Remember our original data, and I'll flip back just to show you for 1 second. Here's our original data. No decimal places, no numbers beyond the decimal point. So we want 1 decimal beyond the decimal point. 1 number beyond the decimal point. Okay. So, like I said, we landed the population variance and standard deviation. We got 6.6. And then if we take the square root of 6.6000 and then round, we would get 2.6. Okay, that's fine. 6.6 seems awfully large. The 2.6 seems right on track for the average variability in those numbers, the average spread in those numbers. Okay, so now let's look at sample variance and standard deviation. Now the only difference is we're going to take 66 and divide by 9. We're going to take 66 and divide by 9. So in this case we get 7 point, and there should really only be 4 3s here. It's okay if you want to do more, but I recommend just holding to 4. Okay, that's all you need to do. And then that rounds to 7.3. Similarly, we can take, to get the standard deviation, we just take that last step of 7.3333, take the square root, and we would get 2.7. So notice here it was 6.6 and 2.6. Here it's 7.3 and 2.7. As I promised, the sample variance and standard deviation are just a little bit larger than the population variance and standard deviation. Okay, and you don't have to really understand why yet. So don't worry about that. I'm just pointing that out. Okay. So we'll be talking about this more in class. You'll be getting to go through an example in class, so stay tuned for that. Other than that, have a great day. Stay well, stay safe, and I'll see you next time.